For 3,000 years, the only way to measure a piece of wood was to lay something rigid against it. A stick, a bone, a strip of bronze. The ancient Egyptians measured in cubits, the length from the elbow to the tip of the middle finger. The Romans used graduated metal rods. Medieval joiners used wooden folding rules, hinged in sections, each one opened and locked by hand. The principle never changed. Measurement required contact and rigidity. You held a known length against an unknown length and compared. By the 19th century, carpenters across the United States carried folding boxwood rules in their apron pockets. 6 inches folded, 24 inches opened. The joints wore loose within a year. The brass hinges corroded. The graduations faded. The rules cracked if dropped on a cold morning. And every time a carpenter needed to measure something longer than 2 feet, he either unfolded a second rule, estimated the gap, or called for a helper to hold the other end. Cloth tapes existed, wound inside small leather cases, but they stretched, they absorbed moisture. They sagged under their own weight the moment they left the case. They were accurate enough for a tailor measuring a waistband or a surveyor laying out a property line on flat ground. They were useless on a construction site where lumber was rough, conditions were wet, and a 1/16 of an inch mattered. The problem was simple and ancient. Measurement was either rigid and short or flexible and unreliable. No tool in history had managed to be both. The solution to that problem would take a basement inventor in New Hampshire, a century-old hardware company in Connecticut, and a series of engineering refinements so quiet and so precise that the result ended up on the surface of the moon. And then, in every kitchen drawer on Earth, the story of that hardware company begins in 1843 in New Britain, Connecticut, a town that would come to be known as the hardware city of the world. Frederick Trent Stanley was 41 years old. He had already tried and failed at manufacturing once before, opening a small facility in New Britain with his younger brother William in 1831 to produce house trimmings and door locks. That business did not survive the panic of 1837. 6 years of financial ruin swept through the American economy, and the Stanley brothers' enterprise collapsed with it. But Frederick Stanley came back. In 1843, he and William opened a new workshop, Stanley's Bolt Manufactory, to produce wrought iron door bolts. The product was unglamorous. The market was local. The operation was small, but the bolts were well made, and in a region filling with factories and houses, well-made hardware was in constant demand. The business grew. Within a decade, the brothers had expanded into hooks, hinges, and chains. In 1852, they incorporated as the Stanley Works, with 5 neighbors joining as investors and a charter from the state of Connecticut. The new company lost money in its first year. Frederick responded by hiring a 19-year-old named William Hart and promising him a promotion if he performed well. Within months, Hart was secretary-treasurer of the company. He would remain there for over 60 years, designing new machinery, inventing the process for cold-rolling steel, and laying the industrial foundation for everything Stanley would become. During Hart's lifetime, annual sales grew from $7,000 to $11.3 million. Hart was one of the most consequential figures in American industrial history that almost nobody has heard of. He took a personal interest in every aspect of the business. He designed the machinery that gave Stanley an edge over its competitors. He invented the telescoping cardboard box for shipping hardware. And he did not merely improve existing processes. He invented the process for cold rolling steel, a breakthrough in metallurgy that allowed Stanley to produce hardware with tighter tolerances and smoother finishes than any competitor in the region. Hart's contribution to the company was not management. It was engineering. He built the machines that built the products. 14 years after Frederick established the Stanley Works, his cousin Henry Stanley founded a separate company in the same town. The Stanley Rule and Level Company, organized in 1857, manufactured boxwood rules, levels, and squares. In 1869, the company purchased the machinery, inventory, and patents belonging to Leonard Bailey, the creator of the Bailey plane, and moved the entire operation, including Mr. Bailey himself, to New Britain. The Bailey plane became one of the most successful hand tools in American history. By 1900, the Stanley Rule and Level Company was the largest manufacturer of planes and related tools in America. For decades, the two Stanley companies operated side by side in the same small Connecticut city. One made hardware, the other made hand tools. Both carried the Stanley name. In 1920, the Stanley Works purchased the Stanley Rule and Level Company and merged the two into a single corporation. The hand tools division was born. The company that would come to dominate the measuring tool market for the next century was now a single entity, headquartered in the same town where it had all started 77 years earlier. 300 miles to the north, in Berlin, New Hampshire, a man named Hiram Farrand was working on a problem that no one had solved. Farrand was not a wealthy inventor. He was not backed by a corporation. He was a man in a basement in New England, studying metallurgy, obsessively testing different formulas of spring steel, trying to produce a strip of metal that could do two contradictory things at the same time. It needed to be flexible enough to coil inside a small case, and it needed to be rigid enough to stand straight out when extended, unsupported, without drooping. The key was the cross-section. A flat strip of steel would droop immediately. Even the strongest spring steel, if rolled flat, would sag under its own weight at anything beyond a few inches. But a strip with a concave-convex profile curved slightly from side to side like a shallow trough would hold itself rigid. The curve gave the steel structural strength along its length, the same principle that allows a thin sheet of paper to support weight when folded into a channel, while still allowing the tape to flatten and coil when wound back into the case. The physics was simple. The metallurgy was not. Finding the exact alloy, the exact thickness, the exact temper, and the exact curvature took Farrand more than 2 decades of trial and error. Farrand struggled with this for over 20 years. Different alloys, different thicknesses, different tempering processes. On January 3, 1922, he received a United States patent for the concave-convex flexible steel tape. He called it the Farrand Rapid Rule. By 1926, Farrand had partnered with the Brown Company in Berlin, New Hampshire, to mass-produce the device. The tape was 6 feet long, coiled by hand inside an open-ended metal can, and could stand straight out from the case for about 3 feet before gravity pulled it down. It had no spring. It had no lock. The user pushed the tape out and pulled it back in manually. But for the first time in history, a carpenter could carry a flexible, rigid measuring tool in his pocket. The product sold. In his first year of independent manufacturing, starting in 1927, Farrand earned over $100,000 in revenue, a figure nearly unheard of for a one-man operation at the time. Over the next 5 years, his company generated more than $1 million in profit. Then the Great Depression hit. Farrand's business collapsed, as thousands of small manufacturers did across the country. Sometime around 1931, Hiram Farrand sold the rights to the Rapid Rule to the Stanley Works for $50,000. Stanley now owned the foundation of the modern tape measure. What it did with that foundation over the next 3 decades would change the tool industry permanently. Through the 1930s, Stanley refined the Farrand tape. The company produced new models with closed cases, better blade coatings, and wider tapes that stood out farther. It introduced nickel-plated blades with black markings, the first effort to make tape measures easier to read in low light. In 1928, Stanley created its first model with a locking but not self-retracting blade, a design that required the user to manually coil the tape back into the case but held the blade firmly at any extended length. Other manufacturers entered the market during this period. Lufkin, based in Saginaw, Michigan, produced well-regarded surveying tapes and pocket rules. Mayhew made the first closed-case concave-convex tape measure in late 1929. Master Rule, Baldwin, and Carlson and Sullivan all entered the space after the war. The flexible steel tape measure was no longer a novelty. It was becoming the standard measuring tool for an entire industry, and Stanley, which had bought the original patent for $50,000, was at the center of it. Then the Second World War arrived. Production slowed, resources shifted to military manufacturing. Stanley Works received the Army-Navy E Award for excellence in war production, converting its factories toward the needs of a country at war. Tape measure output dropped to a fraction of its pre-war levels, and for several years the civilian market went largely unserved. The war ended in 1945. What followed was the largest construction boom in American history. Millions of soldiers came home under the GI Bill. They needed houses. Suburbs erupted across the country. Levittown, Park Forest. Lakewood, entire communities built in months from identical blueprints, each one requiring framing, flooring, roofing, plumbing and wiring. Every carpenter, every electrician, every plumber on every one of those job sites needed to measure. Stanley seized the moment. The company reintroduced its tape measure line and immediately began innovating. It released the first tape measure with a replaceable blade, a feature that extended the working life of the tool and reduced cost for professionals who used their tapes hard every day. Then Stanley introduced the D-shaped case, a housing with a flat bottom edge and a right-angle profile. The flat base allowed a tape measure to stand upright on a surface. More importantly, the square profile of the case itself became a measuring reference. A carpenter could push the case against a wall and read the blade where it entered the housing, using the known width of the case to take accurate inside measurements. It was a subtle innovation, but it changed the way tradespeople worked, and it is the same case shape used on Stanley tape measures today. Stanley also developed the Tru-Zero Hook, a small metal tab riveted to the end of the blade that could slide back and forth by exactly its own thickness. When hooked over the edge of a board for an outside measurement, the hook pulled away from the blade by one hook thickness, giving a true zero reading. When pushed against an inside surface, the hook compressed by the same amount, again reading true zero. The riveted hook compensated for its own existence. It was not loose, it was not broken. It was engineered to move, and every tape measure on the market today uses the same principle. In 1956, Stanley added a spring-driven retracting mechanism that automatically coiled the blade back into the case when released. For the first time, a tape measure was fully self-retracting. No manual rewinding, no cranking. Extend the blade, take the measurement, release the lock, and the spring pulled the tape home. It was the first modern tape measure in the form that every person alive today would recognize. But the single most important innovation was still 7 years away. In March 1963, Stanley Tools introduced the PowerLock tape measure. The PowerLock combined every innovation Stanley had developed over the previous 3 decades into one product, and then added the feature that made it definitive: a thumb-actuated sliding lock built into the top of the case. Previous tape measures either had no lock at all, forcing the user to hold the blade extended with one hand while measuring or marking with the other, or used crude friction locks that bound the blade in place but made fine adjustment impossible. The PowerLock sliding lock was different. A single thumb motion engaged it. The blade held firm at any length. And the lock could be feathered, partially engaged, allowing the user to slide the blade to a precise point and then lock it without releasing and restarting. For the first time, a tape measure could be operated entirely with one hand. Extend the blade. Lock it. Mark the measurement. Release. Retract. All with one hand. The other hand was free to hold a pencil, steady a board, or brace against a ladder. The case was molded ABS plastic, the first tape measure to use it. Previous cases had been die-cast metal, heavier and more expensive to produce but prone to denting and cracking at the seams when dropped from height. ABS was lighter, more resistant to impact, and cheaper to manufacture at scale. It could be molded into the precise D-shaped profile that Stanley had developed in the late 1940s. And it could be produced in the chrome silver finish that would become the visual identity of the PowerLock line for decades. The blade was coated in a bright yellow plastic, a color Stanley called Lifeguard Yellow, chosen specifically for its high visibility on dark job sites and against rough lumber. The markings were black on yellow, the highest contrast combination available. Easy to read in any light condition from full sun to a bare bulb in an unfinished basement. The end hook was the Tru-Zero design. The spring was Stanley's proprietary coilable retracting mechanism. Stanley applied for and received the PowerLock patent in 1963. The patent covered the sliding lock mechanism, the case design, and the integration of the coilable spring within the D-shaped housing. It was not a single invention. It was the convergence of 30 years of incremental improvements, locked together by one patent into a product that set the standard for an entire industry. The same year, 1963, Stanley also opened what it described as the largest hand tool manufacturing plant in the world in New Britain, Connecticut. The PowerLock was the flagship product of the new facility. The timing was not accidental. Donald W. Davis had joined Stanley in the early 1950s and would become CEO in 1966, serving in that role until 1988. He was the most transformative leader in the company's history since William Hart. Davis had travelled to England during the 1960s, where the do-it-yourself home improvement culture was already in full swing. British homeowners were buying professional-grade tools for personal use, rewiring their own houses, building their own shelving, tiling their own bathrooms. Davis recognized that the same movement was inevitable in the United States, that homeowners would want the same quality tools professionals used, and that a reliable, affordable tape measure would be at the center of that shift. He was right. Under Davis's leadership, employment at Stanley doubled to 20,000. Annual sales grew from $230 million in 1966 to $1.9 billion by 1989, the year after he retired. He coined the company slogan that would define Stanley for a generation. Stanley helps you do things right. The PowerLock was the product that proved the slogan true. It was the tool that every professional already trusted, now marketed to every homeowner in the country. 6 years after the PowerLock patent, NASA launched Apollo 11. On July 20, 1969, Neil Armstrong and Buzz Aldrin descended to the surface of the Moon in the Lunar Module Eagle. Michael Collins orbited above in the Command Module Columbia. The mission required over 5 million components across the entire Saturn V rocket and spacecraft system. Each component was selected, tested, and approved under the most rigorous engineering review process in human history. Every material, every fastener, every switch, every instrument had to justify its presence in terms of weight, reliability, and function. Nothing flew to the Moon that had not earned its place. Among those components stored in the landing gear bay of the lunar module was a Stanley PowerLock tape measure. The logic was simple. Astronauts working in pressurized suits with limited dexterity needed a measuring tool that could be operated with one hand. The PowerLock's sliding lock, the feature that had made it the standard on American construction sites, was exactly the mechanism that worked inside a space glove. Extend, lock, read, release, no fine motor manipulation. No two-handed operation. No fragile mechanical complexity. The same design that let a carpenter measure a stud bay while holding a pencil in his other hand let an astronaut measure components on the surface of the Moon while wearing gloves that reduced his grip strength by half. Stanley did not design the PowerLock for NASA. It did not submit a proposal. It did not bid on a government contract. It designed the PowerLock for carpenters and electricians and plumbers on construction sites across the United States. NASA chose it because the design was already correct. The best engineering decision Stanley ever made was building a tool so well suited to single-handed operation that it worked in an environment the company had never imagined. The Apollo 11 tape measure became one of the most quietly celebrated details in the history of the space program. Stanley would later commemorate it with a limited edition PowerLock bearing the Apollo 11 mission insignia. By the end of the 1960s, the PowerLock was the dominant tape measure in the United States. On construction sites, in workshops, in kitchens, in garage toolboxes. The silver-cased yellow-bladed Stanley was the default. When people pictured a tape measure, they pictured a PowerLock. Stanley partnered with DuPont to coat PowerLock blades with Mylar polyester film, a layer that protected the steel from rust, resisted abrasion, and extended the working life of the blade by years. The Mylar coating was invisible to the user, but critical to the longevity of the tool. A coated blade could survive thousands of extensions and retractions, dragged across rough lumber, scraped against concrete edges, dropped onto wet floors, and still read clean and sharp. The company expanded the PowerLock range. Blade widths went from 1/2 inch to 3/4 of an inch to a full inch. Tape lengths grew from the original 6 and 8 feet to 10, 12, 16, 20, 25, and eventually 35 feet. Each size was built on the same platform, same lock, same case geometry, same Tru-Zero Hook, same Mylar-coated yellow blade. The only variables were length and width. Stanley manufactured 31 versions of the PowerLock in 7 different sizes and sold them in 66 countries. More than 9 million PowerLock tape measures were manufactured every year in the original New Britain, Connecticut plant. By 1989, the factory was producing over 200,000 tape measures per day. Then, the patent expired. In the late 1970s, the PowerLock patent reached the end of its protected life and entered the public domain. Every competing manufacturer in the world was now free to copy the D-shaped case, the sliding lock, the coilable spring, and the Tru-Zero Hook design. And they did. Within a few years, the tape measure aisle of every hardware store in the world was filled with products that looked, operated, and measured exactly like a Stanley PowerLock. Cheaper versions, off-brand versions, store-brand versions. The design that Stanley had spent 3 decades perfecting was now available to anyone with a factory and a supply of spring steel. Tom Chang, Stanley's global product manager for measuring and layout tools, would later describe the result directly. When the patent expired, the PowerLock became the most copied tape measure design in the world. Every tape measure you have ever used, regardless of the name on the case, uses the principles that Stanley patented in 1963. Stanley's response to patent expiration was not to retreat, it was to innovate again. In the late 1990s, the company introduced the FatMax, a new tape measure line designed to exceed the PowerLock in every measurable category. The FatMax blade was wider, 1 1/4 inches across, with larger markings and bolder numbers. It used a heavier gauge of steel and a more aggressive concave-convex profile, giving it a standout of 11 feet. 11 feet of unsupported horizontal extension before the blade collapsed under its own weight. For a carpenter working alone on one end of a room, measuring to the opposite wall without a helper, 11 feet of standout was the difference between getting the number and not. The FatMax case was reinforced with a rubber-over mold for impact resistance. The first 4.5 inches of the blade were coated with a secondary layer called blade armor, a reinforced zone that protected the section of tape most vulnerable to kinking and tearing, the part nearest the hook that took the most abuse from daily use. The hook itself was upgraded to a 3-rivet design for greater durability and a multi-catch profile that could grip a surface from the top or the bottom. The FatMax did not replace the PowerLock, it sat alongside it. The PowerLock remained the standard duty tape measure, affordable, reliable, ubiquitous. The FatMax became the premium line for professionals who demanded more standout, more durability, and more blade life. 2 products, 2 price points, the same company, the same New Britain factory. In November 2009, the Stanley Works and the Black & Decker Corporation announced a merger. The deal was finalized on March 12, 2010, creating Stanley Black & Decker, an $8.4 billion global industrial company. Former Stanley shareholders held approximately 50.5% of the combined entity. Former Black & Decker shareholders held the rest. The merger combined Stanley's hand tool dominance with Black & Decker's power tool portfolio, which included DeWalt, the professional power tool brand Black & Decker had acquired in 1960. Under the Stanley Black & Decker umbrella, the company also came to own Craftsman, purchased from the collapsing Sears empire, and Porter Cable, a once legendary power tool brand that had been acquired and, by many accounts, diminished through successive corporate ownership changes. The combined company reported revenues exceeding $15 billion. Stanley Black & Decker is now headquartered at 1000 Stanley Drive, New Britain, Connecticut. The address has not changed since the company moved to its new $8 million headquarters building on August 1, 1984. The factory that opened in 1963, the year of the PowerLock patent, is still producing tape measures on the same site. The tooling has been updated, the automation has been modernized, the output has increased. But the location is the same. PowerLock tape measures roll off the line in the same Connecticut city where Frederick Stanley made his first wrought iron door bolt in 1843. This is not a common outcome in the American tool industry. Across the past 50 years, brands have been bought, sold, merged, gutted, relocated, and discontinued at a pace that makes corporate genealogy nearly impossible to follow. Milwaukee was sold to Tektronic Industries, a Hong Kong conglomerate. Ryobi and Rigid fell under the same umbrella. Porter Cable was stripped of its engineering identity. Craftsman was ripped from Sears and handed to a company that did not build it. Brand names became labels, applied to whatever product a conglomerate decided to manufacture in whatever factory offered the lowest per unit cost. Stanley's tape measure line has survived that pattern. The PowerLock is still manufactured in New Britain. The FatMax is still manufactured in New Britain. The yellow blade still carries the mylar coating. The Tru-Zero Hook still slides by its own thickness. The sliding lock still clicks under a thumb. There is a particular kind of engineering achievement that disappears from view precisely because it succeeds. Nobody thinks about a tape measure. Nobody admires one. Nobody posts photographs of tape measures on social media or debates tape measure specifications in online forums the way they debate cordless drill platforms or table saw fences. A tape measure is a thing you reach for, use, and forget. It sits in a drawer, on a belt clip, on a dashboard, on a windowsill. In a kitchen junk drawer beside dead batteries and rubber bands and a screwdriver nobody remembers buying. That invisibility is the highest form of success a tool can achieve. The tape measure became so reliable, so intuitive, so universally correct in its design that it stopped being a product and became infrastructure. It became part of the background. It became assumed. Hiram Farrand spent 20 years in a basement trying to make a strip of steel that could coil and stand rigid at the same time. Stanley spent 30 years refining the case, the hook, the spring, the lock, the blade coating, and the color of the markings until every variable was resolved. The PowerLock patent of 1963 did not invent the tape measure. It completed it. A carpenter in 1920 carried a folding boxwood rule with brass hinges that measured 24 inches. A carpenter in 1963 carried a PowerLock that measured 12 feet, retracted with a spring, locked with a thumb, and read in high contrast from any angle. A carpenter today carries the same design, 63 years later, because nobody has found a reason to change it. The tool that went to the moon in 1969 is the same tool sitting in your kitchen drawer right now. The same D-shaped case. The same sliding lock. The same yellow blade. The same hook that moves by exactly its own thickness. That is not nostalgia. That is not tradition. That is not a company refusing to innovate. That is a design so correctly resolved in 1963 that over 60 years of engineering progress have found nothing fundamental to improve. The concave-convex blade that Hiram Farrand perfected in a New Hampshire basement. The D-shaped case that Stanley designed during the post-war housing boom. The Tru-Zero Hook that compensates for its own thickness. The sliding lock that NASA chose for the moon. Every one of those engineering decisions was made by a specific person at a specific time solving a specific problem. And not one of them has been overturned. 3,000 years of rigid sticks and stretched cloth, and then 1 century of quiet, relentless improvement by a bolt manufacturer in Connecticut. The tape measure is finished, and the company that finished it started in a small workshop in New Britain in 1843, when a man named Frederick Stanley decided to make door hardware that worked.